What if the universe ends tomorrow? No warning, no time to prepare, just gone. Sounds like a sci-fi movie, right? But here's the crazy part. Scientists actually have theories about how the universe could meet its ultimate fate, from a slow, icy death to a sudden cosmic collapse or even a reality-shattering event that happens instantly. These aren't just wild guesses, they're backed by physics. And the scariest part? Some of them could happen without us ever seeing it coming. So what's the truth? Let's dive into the ultimate doomsday theories and find out how everything we know could end. The Big Freeze. Alright, picture this. You're walking outside one night and for some reason the stars look dimmer. Not just one or two, all of them. The sky feels colder, emptier. Now what if I told you that this is exactly how the universe might end? Not with a bang, not with destruction, but with a slow, agonizing freeze. Scientists call it the Big Freeze or heat death, and honestly it's one of the scariest ways for the universe to go. Right now, our universe is expanding. Galaxies are moving away from each other like people trying to avoid an awkward conversation. But the problem? They never stop moving. Ever. The farther they go, the colder everything becomes. Stars will die, galaxies will vanish, and black holes will eventually evaporate, leaving behind a vast, empty, frozen void. Imagine the last star in the universe, flickering like a dying candle. No more warmth, no more light. Just eternal, infinite darkness. Even atoms might stop vibrating, meaning time itself could just stop. Forever. But here's the real kicker, this isn't something that happens in an instant. It's a slow, inevitable process that would take trillions upon trillions of years. So, if you're worried about waking up tomorrow to an ice-cold void of nothingness, don't be. We still have time. For now. The Big Rip. Okay, imagine you're holding a piece of paper. Now slowly, tear it in half. Now again, and again. Until there's nothing left. Now, apply that same concept to the entire universe, except instead of paper, it's planets, stars, galaxies, even atoms. Welcome to the Big Rip, a theory that suggests one terrifying possibility. Dark energy could one day become so powerful that it overcomes everything. Gravity, nuclear forces, even the very fabric of space itself. Right now, dark energy is this mysterious force making the universe expand faster and faster. But what if that acceleration keeps increasing? What if, in a distant future, galaxies are torn from each other? Then solar systems? Then planets? Eventually, even your body would be stretched and ripped apart, atom by atom. And the worst part, scientists estimate that if the Big Rip is real, it would happen in a sudden, unstoppable chain reaction. First, galaxies separate, then black holes dissolve, then planets and moons start drifting away, until in the final moments, boom, space-time itself is shredded, and the universe as we know it ceases to exist. So, while we might be safe for billions of years, if this theory turns out to be true, well, let's just say we won't see it coming. The Big Crunch. Alright, let's flip the script. What if, instead of expanding forever, the universe suddenly decided to reverse? Imagine watching a movie of the Big Bang, but in reverse. Galaxies stop moving outward and start falling back toward each other. Space itself shrinks. Stars collide. The entire universe begins to implode under its own gravity. This is the terrifying possibility of the Big Crunch. At first, it wouldn't be noticeable. The cosmos is vast, and these changes would happen over billions of years. But eventually things would get weird. Galaxies would merge in violent collisions, black holes would devour everything in sight, and temperatures would skyrocket as matter condensed. Now, picture the very last moments. Everything, stars, planets, dust, even light itself, squeezed into an unimaginable singularity. A point so dense, so hot that the laws of physics completely break down. Sound familiar? Yep. This singularity would look exactly like the one that started the Big Bang. Which raises the question, what if this isn't the first time it's happened? What if the universe doesn't just end, but resets? The Big Bounce theory suggests that once the universe collapses, another Big Bang could ignite a new beginning. A fresh universe with new galaxies, new planets, maybe even new versions of us. So is the Big Crunch the end of everything or just a cosmic reboot? We don't know. But if history really does repeat itself, the universe may be stuck in an endless loop of birth, death, and rebirth. Kind of poetic, isn't it? Vacuum decay. Alright, this one is pure nightmare fuel. Unlike the Big Freeze or the Big Crunch where the universe takes billions of years to die, this could happen at any moment. Without warning. Let me introduce you to vacuum decay, or as some physicists like to call it, the Big Slurp. Sounds funny, right? Yeah, not when you realize what it means. Right now our universe exists in what's called a false vacuum, kind of like standing on thin ice. It feels stable, but beneath us, there might be something more fundamental, something more real. If a quantum fluctuation or some bizarre high-energy event were to trigger a shift, a tiny bubble of true vacuum could form. And guess what? That bubble would expand at the speed of light. You wouldn't see it coming, you wouldn't feel it, it would just happen. 1 second the universe is here, the next, gone. The laws of physics would change instantly. Atoms would stop being atoms. Time and space would cease to exist as we know them. It sounds like sci-fi, but this isn't some horror movie plot, it's actual science. Some physicists believe that if the universe is truly in a false vacuum state, then vacuum decay is inevitable. The only good news? If it happens, we wouldn't have time to process it. No suffering, no pain, just poof. So, will we wake up tomorrow and find out the universe has been rewritten? Probably not, but the possibility alone is enough to keep some scientists awake at night. Sleep well. The big bounce. Alright, let's think outside the box for a second. What if the universe never really ends? What if, instead of collapsing into nothingness or freezing over, it just bounces back? Imagine a giant cosmic heartbeat, expanding, collapsing, expanding again. This is what scientists call the big bounce. It all starts with a big crunch, where everything gets pulled back together, condensed into a singularity. But instead of staying trapped, something triggers another big bang, a new universe bursting into existence, repeating the cycle all over again. And here's where things get really crazy. What if every new universe is just slightly different? Maybe in one version the laws of physics are the same, but galaxies form in completely different places. Maybe in another, the speed of light is different or gravity is stronger, and maybe, just maybe, there's another version of you out there living a completely different life. This theory makes the universe feel less like a one-time event and more like an eternal process. The end? It's just the start of something new, over and over again, and if that's true, then maybe this isn't the first time we've had this conversation. Maybe in some past version of the universe you've already heard this before, and maybe, just maybe, you'll hear it again. The role of dark energy. Okay, now let's talk about the real mystery here, dark energy. If the universe's fate is a movie, dark energy is the director. We can't see it, we don't fully understand it, but it's shaping everything. And depending on what dark energy really is, it could decide which of these doomsday endings actually happens. Right now, dark energy makes up about 68% of the entire universe. It's like a force that's pushing everything apart, making space expand faster and faster. But here's the scary part. We have no idea what it is. Is it a constant force? Will it get stronger? Or could it suddenly change? If dark energy stays constant, the universe might just expand forever, leading us straight into the big freeze. And if it gets stronger, we might be headed for the big rip, where space itself is torn apart. But if it weakens, gravity could take over again, pulling everything back for a big crunch. And here's something even crazier. What if dark energy isn't just controlling this universe, but all universes? Some scientists think that dark energy could be linked to the multiverse, meaning that whatever happens to our universe is just a tiny piece of something much, much bigger. So, will dark energy let the universe drift into an icy grave, rip it apart, or start the cycle all over again? The truth is, we don't know. But one thing's for sure, dark energy is the key to everything. So, is the universe destined for a slow freeze, a violent collapse, or something even stranger? The truth is, we may never know until it happens. But one thing's for sure, the cosmos is full of mysteries waiting to be unraveled. If you love exploring the mind-blowing possibilities of science in the future, make sure to subscribe to InnoVision Tech for more deep dives into the unknown. What do you think will be the universe's ultimate fate? Let's discuss in the comments. What if I told you that for just 1 second, everything stopped? Not just your clock, not just your phone, but time itself, the entire universe frozen in place. No movement, no sound, no light, just complete stillness. Sounds insane, right? But here's the real question. What would actually happen if time stopped for just 1 second? Would you feel it? Would the world change? Or would we never even know? Stick around, because what you're about to hear will make you question everything you thought you knew about reality. Are you ready to dive into the impossible? Let's find out. The nature of time and perception. Imagine if time suddenly stopped, just for a single second. Sounds harmless, right? But hold on, because time isn't just a ticking clock, it's the very thing that keeps reality in motion. From the way we breathe to the way light travels, everything is governed by time. But what if, for a brief moment, time completely froze? Would we even notice it? Well, here's the crazy part: you wouldn't. Your brain, like everything else, relies on time to function. Every thought, every memory, every movement you make depends on time moving forward. If time paused, so would your neurons. Your brain wouldn't even get the chance to register that something strange had happened. Imagine blinking, but in that brief moment, everything, your heartbeat, your thoughts, even the air around you, completely stopped. And yet, when time resumed, you'd continue as if nothing had happened. Think about it like a video game freezing for a second due to lag. The game doesn't realize it's frozen, it just picks up where it left off. The same would happen to you. But here's a fun twist. If time stopped, would light stop too? That means, even if your eyes were open, you wouldn't see anything. The entire world would be trapped in absolute darkness for that one frozen second. And if we go deeper, this raises an even wilder question. If time stopped, but you somehow remained aware, would you feel like you were stuck in eternity? 1 second might stretch into an infinite abyss. Spooky, right? Luckily, your brain won't let you experience that. So, in reality, the biggest mystery of all is, did time ever stop before, and if it did, how would we even know? Physical implications of a time freeze. Let's say time halts. You're in the middle of drinking coffee and suddenly, BAM! Time stops. The coffee mid-air freezes, the steam rising from the cup, suspended like an invisible sculpture. But the real question is, what happens on a deeper level? First off, all movement in the universe would come to a standstill. Atoms would stop vibrating, which means heat would cease to exist. Every object from your body to the sun would instantly drop to absolute zero. But here's the twist, you wouldn't feel cold. Why? Because you wouldn't even be able to process the change. Your nerves wouldn't work, your brain wouldn't function, and even your very thoughts would be put on hold. Then, there's light. Light moves at 299,792,458 meters per second. But if time stopped, light wouldn't move at all. That means the entire universe would be trapped in absolute darkness. Even if the sun was shining, its rays wouldn't reach your eyes until time resumed. Imagine someone flipping a switch and shutting off all light instantly. Except in this case, it's not just the lights in your room, it's every photon in existence. And here's where it gets weirder. What about air? Normally, air molecules zip around, allowing you to breathe. But if time froze, they'd stop moving too. That means for that 1 second, oxygen wouldn't reach your lungs, but don't panic. You wouldn't suffocate because, well, your lungs wouldn't be working either. Time would unfreeze, and you'd continue as if nothing happened. So, the next time you take a deep breath, look at the sky, or feel warmth on your skin, just remember, time is what makes it all possible. And if it ever stopped, even for just a second, the entire universe would hold its breath with you. Biological effects on living organisms. Let's talk about life itself. Your heart, your breath, your very existence. Everything in your body depends on time moving forward. But what happens if time stops for just 1 second? Would you feel it? Would it harm you? Here's the surprising answer: no, you wouldn't feel a thing. That's because the biological processes inside you are just as tied to time as everything else. Your heart beats, your blood flows, and your cells divide. All of these depend on time's steady movement. If time stops, so do you. It's like hitting the pause button on a movie. Nothing changes, but nothing moves either. Your body would be frozen in place, your brain would stop thinking, and even your sense of awareness would be suspended. And here's the freaky part: if everything about you stopped, you wouldn't even know time had paused in the first place. Your body wouldn't age, your cells wouldn't decay, and technically you wouldn't even be alive in that moment, but once time resumes, your body picks up right where it left off, as if nothing ever happened. But here's where things get really strange. Imagine you're blinking right when time stops. Your eyelids would freeze mid-motion, leaving your vision locked in place. If you were walking, your muscles would be frozen in action, defying physics for just a split second. And what about people in mid-sneeze? Would they be stuck with the world's longest ah-chew? The truth is, time's flow is what keeps all living things functioning. If time ever stopped, even briefly, life itself would hold its breath, waiting for the next second to arrive. And yet, because we experience time so seamlessly, we'll never know if it's already happened before. Technological and mechanical consequences. Now let's talk about the world around us. Machines, vehicles, the internet, and all the technology we rely on daily. If time stopped, would your phone glitch? Would planes fall from the sky? Would your favorite video game freeze mid-frame? The short answer, yes, but only for that brief second. Every piece of technology we use operates based on time. Clocks tick forward, computers process data, and electricity flows through circuits. All of it requires time to function, so if time stopped, everything electronic would pause too. Your phone screen would freeze mid-scroll, your Wi-Fi would halt, and even the electrical signals running through power lines would be suspended. Now, here's a mind-blowing thought. Cars, planes, and trains all rely on movement through time. If time stops, a speeding car wouldn't crash, because it wouldn't be moving at all in that moment. A plane in midair would hang in place, defying gravity for that 1 second. The entire world would be a frozen snapshot, paused in perfect stillness. And what about artificial intelligence? Could a supercomputer realize that time had paused? Not a chance. Just like our brains, AI needs time to process information. If time stops, it stops thinking too. It wouldn't detect the pause because in its reality there was no pause. The moment time resumes, it continues processing as if nothing happened. And here's where it gets even wilder. Would digital timekeeping devices skip a second, or would they stay perfectly accurate? Since they rely on electrical pulses that measure time, a 1-second stop might throw them off ever so slightly. But in a world where time is back on track, who would even notice? So the next time your computer lags or your phone screen freezes for a second, just ask yourself, what if time actually did stop for a second and we all just missed it? Psychological and philosophical considerations. Alright, let's get deep for a second. If time stops, do we stop existing? Think about it. Our entire experience of reality is tied to time. Every thought, memory, and feeling happens in a sequence. But what if time itself was put on pause? Would we even be aware of it? Here's the trippy part. You wouldn't even realize that time had stopped. Your consciousness, your awareness, your very sense of self would be frozen, just like everything else. It's like someone pressing pause on the universe. The second time resumes, everything picks up where it left off, and you have no clue anything ever happened. It's a bit unsettling, isn't it? Now let's push this even further. What if time has already stopped before? Maybe it pauses for a second every few thousand years and we just don't know it. Maybe right now, time has stopped, and you're frozen in place, unable to perceive the stillness. And the moment it resumes, well, you're right back to reading this sentence as if nothing happened. Then there's the ultimate question. If time stops, does reality still exist? Time and space are deeply connected, meaning if time ceases, does the universe even remain? It's a classic philosophical paradox. Does reality require time to exist, or could the universe just hang in place, waiting to move again? And if we go even crazier, what if time isn't real at all? What if time is just a human-made construct and the universe moves in ways we can't even comprehend? Maybe we're living in a cosmic illusion where time is just an illusion of motion. If that's the case, then stopping time wouldn't just freeze the world. It might break the very foundation of reality itself. 1 second. That's all it would take to change everything. Or maybe it already has. Theoretical physics perspectives. Now let's get scientific, because if anyone can explain what happens when time stops, it's physicists. But here's the kicker. According to physics, time stopping shouldn't even be possible. Time isn't just a background setting, it's woven into the very fabric of the universe, tied to space itself. Stopping time would mean disrupting space-time, which could have insane consequences. For starters, Einstein's theory of relativity tells us that time is relative. It speeds up or slows down depending on gravity and motion. But completely stopping time? That's next level. If time froze, space-time itself would be affected. Would the universe continue existing in a paused state? Would everything collapse into chaos? And let's talk about quantum mechanics, the science of the tiniest particles. On a quantum level, particles are always in motion, constantly shifting and vibrating. If time stopped, these particles would freeze in place. That means no atomic activity, no light movement, no energy transfers, literally nothing happening. It's a complete shutdown of the universe at its most fundamental level. But wait, it gets weirder. Some physicists argue that time is just an illusion. According to certain theories, time isn't something that moves. It's just a way we perceive changes in the universe. If that's true, then stopping time wouldn't actually do anything, because there's nothing to stop in the first place. Mind blown yet? So let's sum this up. If time stops everything, energy, motion, thought, light ceases. But since time itself is part of space-time, freezing time might be impossible without breaking reality itself. And if it ever did happen, we wouldn't even know. So the real question is, what if time has already stopped, but we're just living in its resumed state? What if we're part of a cosmic play button being pressed over and over? Maybe time itself is the biggest mystery of all, and we're just along for the ride. And that, my friends, is the mind-bending reality of time. Did time ever stop before? Would we even know? The universe is full of mysteries, and this is just the beginning. If you love diving into mind-blowing theories like this, make sure to hit that subscribe button and turn on notifications so you never miss a video. What do you think would happen if time stopped? Drop your thoughts in the comments. This is InnoVision Tech, and I'll see you in the next one. Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal, but according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother? You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure, the more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. What if right now, in another universe, you're living a completely different life? Maybe you're a famous actor, a billionaire, or even an astronaut exploring a distant planet. Sounds crazy, right? But what if science says it's possible? The idea of parallel universes isn't just science fiction, it's something real physicists are actually exploring. But here's the big question. If alternate realities exist, could we ever travel between them? Could déjà vu be a glitch between worlds? Stick around, because we're about to dive into one of the biggest mysteries of the universe, and you might never see reality the same way again. The multiverse concept. Have you ever stopped to think, what if there's another version of you, right now, living a completely different life? Maybe in some alternate reality you're a famous musician, a billionaire, or even an astronaut exploring Mars. Sounds crazy, right? But hold on. Science suggests that this idea might not be as far-fetched as it seems. The multiverse theory proposes that our universe is just one of many, an infinite number of realities where every possible version of your life plays out. In one universe, you might have taken that job offer you turned down. In another, you never even existed. It's like a cosmic choose-your-own-adventure book, but every choice actually happens in a separate universe. Why does this idea matter? Well, if alternate universes exist, it changes everything we know about reality, fate, and free will. What if our dreams, déjà vu moments, or gut feelings are actually glimpses of another version of ourselves living in a parallel world? What if those unexplained coincidences, meeting a stranger who feels oddly familiar, or predicting an event before it happens, aren't coincidences at all? The possibility of an alternate universe isn't just science fiction. Physicists, mathematicians, and even philosophers have spent years trying to crack this mystery. Could it be that we are just scratching the surface of something far bigger than we can comprehend? Buckle up, because the journey into the multiverse is about to get a lot deeper. Scientific theories of parallel universes. Okay, so let's get one thing straight. This isn't just wild imagination. There are actual scientific theories that hint at the existence of multiple universes, and they come from some of the brightest minds in physics. One of the biggest ideas, the many worlds interpretation. This comes straight from quantum mechanics, the branch of physics that deals with the tiny, bizarre world of particles. According to this theory, every time a decision is made, every single choice, no matter how small, the universe splits into multiple realities where every possible outcome actually happens. Right now, in some alternate universe, another version of you picked a different career, moved to another country, or even skipped watching this video. Then there's the cosmic inflation theory. Ever heard of the Big Bang? Scientists believe that during the very early moments of our universe, it expanded at an insane rate, like a balloon inflating super fast. This theory suggests that different parts of space might have inflated at different speeds, creating separate independent universes, each with its own laws of physics. That means somewhere out there could be a universe where gravity works differently, where light travels at a different speed, or where time itself doesn't even exist. And get this, some researchers even believe that black holes might be portals to other universes. When something falls into a black hole, it gets crushed into oblivion. Or does it? Some theories suggest that instead of being destroyed, that matter is actually transported to another universe entirely. So what does this all mean? If these theories hold up, then parallel universes might not just be possible, they might be inevitable. The real question is, will we ever find a way to travel between them? Implications of alternate realities. Now, here's where things get personal. If alternate universes really exist, then who are you? Are you just one version of yourself out of an infinite number of possibilities? Think about it. If there are multiple realities where different versions of you exist, does that mean your identity isn't as unique as you thought? Let's say you made a life-changing decision a few years ago. Maybe you quit your job, moved to a new city, or broke up with someone. According to the multiverse theory, in another universe there's a version of you who made the opposite choice. That version of you might be living a completely different life right now. Maybe they're thriving, maybe they're struggling, but either way they exist. This also raises the question, how much of our lives are actually in our control? If every possible choice creates a new reality, then, technically, every version of your life is happening somewhere. Does that mean free will is just an illusion? Or does it mean that every decision, no matter how small, matters more than we ever realized? And here's something even weirder. What if we sometimes feel these alternate versions of ourselves? Have you ever experienced a moment where you knew something was going to happen before it did? Or felt an unexplainable connection to a place you've never been before? What if those are glimpses of another reality bleeding into our own? If alternate universes exist, then your entire sense of self might be way more complicated than you ever imagined. Maybe you're not just you're part of something much, much bigger. Cultural and philosophical perspectives. The idea of parallel universes isn't just a scientific curiosity, it's something that has fascinated humans for centuries. Across cultures, religions, and philosophies, there have always been stories about other versions of reality. Take Hinduism and Buddhism, for example. Both traditions talk about the idea of multiple worlds and different versions of existence. In some interpretations, karma doesn't just affect your next life. It could also play out across multiple realities at once. Could these ancient beliefs be an early glimpse into what science is now exploring? Then there's philosophy. Ever heard of the what-if paradox? It's the idea that every decision creates an alternate path. Some philosophers believe that every choice we make splits reality, which means infinite realities exist, each one shaped by a different version of your past decisions. Sound familiar? That's basically the many worlds interpretation, but through the lens of philosophy instead of physics. And of course, we see the idea of alternate realities everywhere in pop culture. From Marvel's Multiverse of Madness to Stranger Things, from Rick and Morty to Interstellar, the concept of multiple universes is a storytelling goldmine. Why? Because deep down we all wonder, what if my life had gone differently? But here's the real kicker. What if these stories aren't just fiction? What if we're drawn to these ideas because on some subconscious level we know there's truth to them? Maybe, just maybe, the reason we love stories about parallel universes is because our minds are already connected to them in ways we don't fully understand yet. Technological advances. Alright, let's get to the big question. Can we actually prove that alternate universes exist? Right now, we can't exactly hop into a spaceship and visit Earth 2, or shake hands with an alternate version of ourselves, but that doesn't mean scientists aren't trying. One of the most exciting areas of research is quantum computing. Unlike regular computers which use bits, quantum computers use qubits, which can exist in multiple states at once. Some physicists believe that this strange behavior hints at parallel worlds interacting with our own at the microscopic level. Could quantum computers one day help us access these other realities? Then there's the Large Hadron Collider, the massive particle accelerator beneath Switzerland. Some scientists speculate that high-energy particle collisions could create tiny, mini black holes, which might provide evidence of other dimensions or universes. In other words, we might be closer than we think to unlocking the secrets of the multiverse. And let's talk about dark matter, the mysterious invisible substance that makes up most of the universe but doesn't interact with light. Some scientists believe that dark matter could be leaking in from parallel universes. Imagine that. What if an entire hidden reality is right next to us, but we just don't have the tools to see it yet? The bottom line? We might be on the verge of one of the biggest discoveries in history. If alternate universes exist, science will find a way to prove it. And who knows? Maybe one day, we'll find a way to travel between them. The allure of the unknown. So after all of this, where does that leave us? Is there really another version of you out there living a different life? Maybe, maybe not. But here's the thing. The possibility alone changes everything. Think about it. If alternate universes exist, it means every choice you've ever made has played out somewhere. Every dream you've had, every risk you didn't take, every what-if moment, it all exists somewhere in the vast multiverse. And if that's true, then what does it say about the life you're living right now? What if we're more connected to these alternate realities than we realize? What if those strange moments, déjà vu, vivid dreams, unexplainable instincts, aren't just random, but glimpses of something bigger? What if the universe isn't just a place but a network of infinite possibilities, all playing out at the same time? One thing's for sure, the more we learn about the universe, the more mysterious it becomes. And whether or not we ever find proof of the multiverse, one thing is undeniable. The search for answers is what makes us human. Because in the end, we aren't just looking for other universes, we're looking to understand our own. The idea of alternate universes is mind-blowing, but what if it's more than just theory? What if every choice, every possibility is playing out somewhere right now? Science is getting closer to unlocking these secrets, so who knows what we'll discover next? If you enjoyed this deep dive into the unknown, make sure to subscribe to InnoVision Tech for more mind-expanding content. Hit that like button, drop a comment, and let's keep exploring the future together. See you in the next one.